Okay, so in this question, we're looking at ExamCraft 2019, paper 1, question 6, leaving cert higher level maths. It says differentiate 6 minus 4x minus 3x squared from first principles. So first thing you should really do is write out that, f dash of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. We know that our f of x is given to us. We know then to find f of x plus h, all you need to do is wherever there is an x, sub in x plus h. And it's important here that it's going to be squared, x plus h squared. So we continue to multiply those out then, our f of x plus h. Important that here we're squaring out the bracket carefully and continue to multiply it out further before you then sub it into this formula up here. Okay, so this formula, same formula that I've written there, wherever you have f of x plus h, you're subbing this in, making sure we keep our minus, and then we're using our f of x. When you multiply this out, you'll find that the minus 6, this becomes a plus 4x, and this becomes a plus 3x squared, is going to cancel with 3x squared, the plus 4, the minus 4, and the plus 6. When we get down to this point, make sure we're writing our limit as h goes to 0 all the way down until the very last step. Okay, on the right hand side of the equals, make sure you keep writing that down, limit as h goes to 0. We cannot set the limit or h equals to 0 at this point, because if we had 0 on the bottom line, we would be dividing by 0 and the world explodes if we ever divide by 0. So out of the top line, I factorize out h. H divided by h is 1. So now we don't have a h on the bottom line, and now I can set h is equal to 0. So setting this equal to 0, you're going to get 0 there, and we're getting our final answer. Okay, you can check your answer by differentiating by rule. 6 would go to 0, the minus 4x would go to minus 4, the minus 3x squared would go to minus 6x. And we've gotten that, so we know we're correct. The next part of it is, given the function f(x) equal to 1 over x plus 2, show that the function has no turning point. Okay, well, if it has no turning point, its slope, or its dy dx, because that's what slope stands for, dy dx, or dy dx stands for slope, is either always positive or negative. So I go and actually differentiate this. I know my u is 1, my du dx is going to be 0, my v is x plus 2, and my dv dx is 1. I'm going to use the quotient rule, which is in your log tables, page 25, the quotient rule, to go and differentiate it. Okay, so at this point, you can go one of two ways. You can say, well, if it has a turning point, f dash of x must equals to 0. Okay, so I've set f dash of x equals to 0. I multiplied both sides, so from here, I multiply both sides by the bottom line, so 0 by x plus 2 squared is just going to be 0, so you get minus 1 is equals to 0, but that doesn't make sense, so therefore there is no turning point. Or you could follow this piece of logic here that says from here, f dash of x is always negative. The reason, and I'm actually going to talk about this in the next question, so I'm just going to scroll down to the next bit, because it says a student states that the function in part bi is always decreasing. So the function was f dash of x equal to minus 1, the function was f of x is equal to 1 over x plus 2. That was the function. Do I agree with the student? Yes. The reason for that is because its slope, its slope is this. Its top line is always negative. Minus 1 is always negative. And the bottom line is always positive, because anything squared is positive. Pick any number, square it, it's always positive. Okay, so if we know we have a negative over a positive, we know we're going to get a negative. So its slope is always decreasing, because a positive or a negative over a positive is a negative. And that's it. Really short question, to be honest. Quite a nice question. Marks for it, 15 marks for first principles. You should be really, really happy with that, and that obviously means 5 and 5 for the next two. A really nice question.